वेलकम इन अनदर वीडियो ऑफ फिजिक्स स्टूडेंट। लास्ट लेक्चर में हमने एक्सपेरिमेंटल सेटअप फॉर फोटो इलेक्ट्रिक इफेक्ट का डिटेल स्टडी किया था। ठीक है, उसके बाद हमने जो एक्सपेरिमेंट पे ऑब्जर्वेशंस है उसका स्टडी स्टार्ट किया था। तो उसमें हमारे फर्स्ट 3 ऑब्जर्वेशन कंप्लीट हो चुके हैं। तो आज के इस वीडियो लेक्चर में हम रिमेनिंग जो ऑब्जर्वेशंस है फॉर फोटो इलेक्ट्रिक इफेक्ट तो उसका हम डिटेल स्टडी करेंगे। तो शुरू करते हैं आज का वीडियो। सो जो फोर्थ ऑब्जर्वेशन है फॉर द फोटो इलेक्ट्रिक इफेक्ट इज द फोटो करंट आई कुड बी वेरिड बाय चेंजिंग द पोटेंशियल ऑफ द कलेक्टर प्लेट। ठीक है, तो जैसे हमने एक्सपेरिमेंट में देखा, देर इज़ अ इमीटर प्लेट विच इज़ मेड ऑफ मेटल एंड देर इज़ अ collector plate at the opposite side. So electrons emitted from the emitter plate is collected by the collector plate. Okay, so photocurrent I should be vary by changing the potential of collector plate because both the plates are connected to the variable voltage source. Okay, so when we can vary the voltage of the collector, then the photocurrent is also vary. So I was depend on the accelerating potential V. ठीक है, means जो current है that will depend on the accelerating potential V. So potential difference between the emitter and collector. तो जो current I that can be flow through this circuit, so that will be depend on the difference between the this emitter and the collector voltage. Next point, for a given incident radiation, so intensity and frequency were fixed when the light source will emit the light on the emitter, means the light source will incident on the emitter plate. Then at that time the intensity and frequency were fixed. So this emitter and collector potential difference that causes the current I to be vary. So initially the current increase with the voltage, मीन्स यहाँ पे क्या होगा, जैसे ही वोल्टेज इंक्रीज होगा then at that time the current is also increase, but then it remains constant, but after some time it remains the constant. This was termed as a saturation current I0 and that current is called as a saturation current I0. Okay, so when initially the current is get increase, photocurrent is get increase with the increase in voltage. जिस तरह से आप voltage increase करोगे from this variable voltage source, the potential difference between this emitter and collector plate, because both are connected to the this voltage source, so at that time current is also increased, but after some time the current remains the constant, so that is called as a some saturation current. It is denoted by I0. ठीक है, तो अभी हम ग्राफ में देखते हैं तो आपको क्लियरली समझ में आएगा। तो यहाँ पे फोटो करंट I, बिकॉज फोटो करंट इज डिनोटेड बाय I विच इज़ इन माइक्रो एम्पियर, जैसे हमने एक्सपेरिमेंटल सेटअप में देखा, एंड इट इज़ I वर्सेस द एक्सेलरेटिंग पोटेंशियल. सो व्हेन द इंटेंसिटी ऑफ light will be increased, at that time the voltage is also get increase. Okay, so that is the current values are given, that is I0, then I10, I30. Okay, so the current is goes on increasing by increasing the intensity of light. So that is the graphical representation of the photocurrent. So when the intensity of light is low, so voltage is and the current is also low, and when it goes on increasing, the light intensity is also getting increased, and that will affect on the photocurrent I. So that is the fourth observation from the experiment of photoelectric effect. Next is the fifth observation from the experiment. Keeping the accelerating voltage and incident frequency fixed, if the intensity of incident radiation was increased, the value of saturation current is also increased. जैसे हमने यहाँ पे ग्राफ में देखा कि by keeping the accelerating voltage and incident फ्रीक्वेंसी फिक्स, जो लाइट सोर्स हमने यूज़ किया है एस, दैट इज द सोर्स ऑफ लाइट, by keeping the accelerating voltage and the incident frequency of the light that is fixed if the intensity of incident radiation was increased. अगर इसका इंटेंसिटी हम इंक्रीज करते मीन्स फ्रॉम लो इंटेंसिटी टू द हाई इंटेंसिटी, then at that time the value of saturation current is also increase proportionally. ठीक है, जैसे हमने ग्राफ में देखा, फर्स्ट इज I0 that is at the low intensity of light. When we increase the intensity of light, then it will be a I01. Then again increase the intensity of light, it is I02. So that is the saturation current. Okay, if the intensity was double, the saturation current is also double. When the intensity of light will increase, means it is double, then at that time the value of saturation current is also double. Means in short, the intensity of light is directly proportional to the saturation current. If the intensity of light goes on increasing, the saturation current is also goes on increasing. ठीक है, यहाँ ग्राफ में दिखा है यहाँ पे. ठीक है, तो यहाँ पे I0 का वैल्यू क्या हो रहा है, चेंज हो रहा है, दैट इज फ्रॉम लो इंटेंसिटी टू द हाई इंटेंसिटी, द वैल्यू ऑफ करंट is also goes on increasing. Okay, so that is the fifth observation from the experiment. Next, sixth one is the maximum kinetic energy. It is denoted by Ke, and hence maximum velocity of the electron depend on the potential V. ठीक है, तो जो इलेक्ट्रॉन्स इमिट्स हो रहे इमिटर प्लेट से, ठीक है, so that has the kinetic energy. It is denoted by Ke max, and that depends on the voltage V for a given metal used for the emitter plate. तो जैसे हमने एक्सपेरिमेंटल सेटअप जब स्टडी किया तो हमने देखा कि इमिटर इज़ मेड ऑफ अ मेटल. ओके, तो ये मेटल से बनता है. सो फॉर अ गिवन फ्रीक्वेंसी ऑफ इंसिडेंट रेडिएशन, दैट मेटल एग्जिबिट्स सम प्रॉपर्टीज. ओके, सो दैट emits the electron according to the metal used for the manufacturing of this emitter plate. So if the material is change, ठीक है, अगर हम material means metal अगर change कर रहे हैं, so that the frequency of incident radiation is also change. ठीक है, अगर आपने material change किया, then the frequency of incident radiation is also change. So Ke max is also change if did not depend on the intensity of incident radiation. ठीक है, तो ये जो लाइट सोर्स से जो लाइट इंसिडेंट हो रहा है उसकी इंटेंसिटी पे ये डिपेंड नहीं है. इट विल डिपेंड ऑन द मेटल यूज फॉर मैन्युफैक्चरिंग द इमिटर प्लेट. सो दस इवन फॉर अ स्मॉल इंसिडेंट इंटेंसिटी, इफ द फ्रीक्वेंसी ऑफ इंसिडेंट रेडिएशन वॉज लार्जर than the threshold frequency V0. V0 is nothing but the threshold frequency. So K max from a given surface was always same for the incident frequency. So that is the sixth observation from the experimental setup. Means in short, the kinetic energy will depend on the potential V, but the potential V will depend on the metal which is used for the emitter plate. So it doesn't depend on the frequency of incident radiation. Okay, so that is the sixth observation from the experimental setup. Then we start with the seventh observation. So in that, if increasingly negative potential were applied to the collector, means for the collector plate we apply the negative potential, means the variable voltage source we use, so we apply the negative voltage to the collector. The photocurrent decrease, so at that time photocurrent I will be decrease, and for some typical value minus V0, photocurrent becomes the 0. When we increase this voltage, negative voltage which is given to the collector plate, so at that time photocurrent start decreasing, means photocurrent क्या होगा, कम होगा. But at that some typical value means minus V0, at that time photocurrent becomes the 0, means this I is completely 0. V0 was termed as a cutoff or stopping potential. So this V0 is nothing but the stopping potential. It indicates that when the potential was retarding means reverse, okay, because we are applying the negative voltage to the collector plate, so that is called as a retarding. The photoelectrons will had enough energy to overcome the retarding means opposing the electric field and reach to the collector, ठीक है. तो इससे क्या होगा, रिटार्डिंग पोटेंशियल वहाँ पे डेवलप होगा एंड दैट फोटो इलेक्ट्रॉन्स विल हैव द इनफ एनर्जी टू ओवरकम द रिटार्डिंग मीन्स अपोजिट force of electric field and reach to the collector. Then the value of V0 was same for the incident frequency as long as the incident frequency was same. Means जो value है कट ऑफ वोल्टेज V0 की was same for any incident intensity as long as incident frequency is same but was different for different emitter materials, ठीक है. तो ये डिपेंड होगा डिफरेंट इमिटर मटेरियल पे. जैसे हमने लास्ट ऑब्जर्वेशन में देखा voltage V is completely depend on the metal which is used for the this emitter plate manufacturing, ठीक है. So that is the 7 observation from the experimental setup. Then we start with the 8 observation. If the frequency of incident radiation was changed by keeping the intensity and accelerating potential V constant, then the saturation current remains the same but the stopping potential V0 is changed, ठीक है. When the frequency of incident radiation, जो light incident हो रहा है on emitter plate और उसका frequency will be changed by keeping the intensity, ठीक है, and the accelerating potential V मीन जो intensity रहेगा light का वो हम constant रखेंगे and the voltage which is applied between the emitter and collector plate it is constant, then the saturation current I0, saturation current is denoted by I0, remains the same means I0 is constant but the stopping potential V0 is changed. जो कट ऑफ वोल्टेज है जो हमने लास्ट ऑब्जर्वेशन में देखा but that can be a change, so this V0 will be changed but the saturation current is constant. So that is the observation. This observation is dissipated as shown in below figure. The stopping potential V0 vary linearly with V. For different metals, the slopes of such straight lines were same, but the intercepts on the frequency and stopping potential axis were different. So this is the graph given for photocurrent I versus the accelerating potential. Okay. तो यहाँ पे saturation current is denoted by I0 and these are the different cutoff voltages are given. V0 is the cutoff voltage, so it is a reverse voltage, that's why it is indicated by minus. So minus V01, minus V02, minus V03, we are increasing the negative voltage. Okay, so that is the observation 8 from the experimental setup. Then ninth observation from the experiment is the photocurrent, that is I, and hence the number of electrons depends on the intensity but not on the frequency of incident radiation. तो जो photocurrent I0 है or simply I and the number of electrons that can be emitted from the emitter plate towards the collector, so this does not depend on the frequency of incident radiation as long as incident frequency was larger than the threshold frequency, ठीक है. तो जो incident frequency when it is larger than the threshold frequency is denoted by V0 and the potential of anode was higher than that of cathode. This anode is nothing but the emitter and the collector is nothing but the cathode. It is denoted by K. When anode is positive with respect to this cathode, then we can say that it is electrons are emitted at the higher velocity from this emitter plate towards the collector. Okay, So that is the experimental setup 9 observations. Okay, so that is the stopping potential V0 is there, incident frequency is denoted by V. So this is depend on the metal which is used for the making of this emitter plate. So two metals are used, metal A and metal V. So these are the observations for the experimental setup for the photoelectric effect. तो आज का ये वीडियो लेक्चर हम यही एंड करते हैं. नेक्स्ट वीडियो लेक्चर में हम स्टार्ट करेंगे वेव थ्योरी. सो थैंक यू.